Hello everyone, my name is Amir Siddiqui. I am working as a data scientist with T Systems India. And if you want, you can connect with me on LinkedIn. So this is my LinkedIn ID here. Today we will be talking about how we can evaluate RAG model performance. Let's start now. So this is the content that we are going to go through in this session. We will see what is RAG, the benefits of RAG, how we can create a RAG pipeline, and once we create a RAG pipeline, how we can evaluate it, what are the different metrics that we can use for RAG evaluation, how we can detect bias, and what are the different tools that we can use for evaluating RAG performance. So there are some open source tools that we will see. Now let's start with the introduction. So you all must have used ChatGPT or any other large language model, and you must have asked a question to it and you got the answer. But you would also like to know whether the answer that you have got is actually correct or not. So that is where the evaluation part comes. We are always asking the question, but we don't know whether the answer that has been given is correct or not. Let's consider an example. You ask a medical question to a LLM model, and that LLM model gives you some answer. You are asking a question like, "Give me how to cure some particular disease," and then it gives you some answer. You go to the doctor and you again ask that same question to the doctor, and you tell that doctor that you got this answer from the large language model, and the doctor says no, it is completely wrong. So this is where the evaluation part comes. When you are building a rack pipeline, you also need to evaluate, and you also have to confirm that the answer that you have got is actually correct. So in this session, we will see how we can evaluate our RAG and how accurate it is, how fair it is, and how understandable it is. Let's first try to understand what is RAG. So the full form of RAG is Retrieval-Augmented Generation, and it has a two-part architecture. It has one retriever, and the second one is generator. So retriever will fetch all the important documents from a knowledge base, and a knowledge base could be anything. It could be your CSV file, PDF file, or any online website. And then the next is generator. Once it fetches all the important documents from that knowledge base, then it will create a response for you using some LLM that you will be using. You can use any LLM here, some open source or OpenAI's GPT-4 or any other new LLM that is available in the market. And to give you an example of how RAG is, so let's say you are asking some query to the LLM model. So the retriever part will find the best article on that topic. So there are many topics you will find on the internet, but retriever's job is to find the best one. And then generator is something that will read all of those best materials that retriever has collected, and then it will summarize the answer for you. So that is where these two components together works. Now, why do we need RAG? What are the benefits of RAG? Because we already and we are using our chat GPT or Gemini, and nowadays we have DeepSeek. So why do we need RAG if we already have these LLM models? So the thing is that these LLM models that you are using, they have information till some date. So if you use chat GPT, it has information till 2023 or 2024. It doesn't have the latest information. The second one is it is trained on the public data set. So the data set which is available in the public domain for free. It is not trained on the data set that you have, your personal data set, or even the organization, they are having their own personal database. They have their data collected in CSV file or PDF file, or they have data lake, data warehouse. So those data are not exposed to the LLMs. So you cannot get answer to the specific question that you are asking, which is related to your personal data. That is where RAG comes. So it will give you the power to train the LLM model on your specific data set, on your domain. So if you are coming from, let's say, a finance domain or healthcare domain, so you can use your own data set there, and then your RAG will answer you, or the question that you will answer, the question that RAG will answer will be based on the data set that you have provided, not just the public data set that each and every LLM is having knowledge of. So once you got this answer from the RAG pipeline, you also would like to know whether the answers are correct or not, because you cannot blindly trust that the answer that you got from this RAG is actually correct. So there comes the evaluation part. And if you no machine learning, so in machine learning we also have this evaluation. You have a classification problem, you have a regression problem, and for both of them you have different metrics that can be used for evaluation. So for regression we have rmscp rmsc mape r square. And if you talk about classification, then we have metrics like precision, recall, f1 score, accuracy. Similarly, in RAG also, we have some evaluation metrics that we need to use, and we need to test out to see whether the output that we are getting or the answer that we are getting is actually correct. So as it has two architecture, retrieval and generation, so we have different metrics for retrieval and different metrics for generation. Now, let's see how our RAG pipeline looks like before we even talk about the evaluation metrics. So you have your data set. Data set can be a CSV file, a PDF file, or a database, a data lake, or data warehouse. So you will extract or you will import the data from these different data sources. Once you have imported this data, you need to break that entire data into different chunks. So chunks is nothing but breaking that large data into small size. And when you are creating these chunks, you get the option to define how how small or how big you chunk you want. So you can pass that parameter when you are calling different function to create chunks. Now, once you have split the data into smaller parts, that is, you have created chunks. The next part is you have to convert these chunks into embeddings, because these are text. And you know that the machine learning model, they only understand numbers. So when you create embeddings, you are actually converting this text into numbers. Now, to create these embeddings, there are different models that are available in the market. Some of them are free, some of them are paid, and you can use any of the embedding model to create embeddings of your text. Now, once you have created these embeddings, the next part is to store this embedding in a vector store. So vector store is where you can store this embedding. It is a special kind of database, because you cannot store these embeddings in a relational database or a NoSQL database. It has its own database, which is a vector store. And now there are different vector stores. One is ChromaDB, then we have Pinecone, FAISS, and there are many other vector database that you can choose. Now, once you have stored this embedding in this vector store, the next part is retriever. Now you will run your query. Retriever will go. It will find the top k similar chunks to the question that you have asked. So k here is the number of relevant document that you want to find out from that vector store. So you can give k any number. It could be 2, it could be 5, 10, 15, any number you can give. But it is always advisable to give a small number because, for example, if you're searching something on Google, what you do, you get your search results and you click on the first or the second link. You hardly go to the next page because you want to find the information in the first page itself, and in that first page also in the first or second link itself. So that is where this top k come. You can give the number of k here. You, if you say 5, so it will give you 5 relevant document, and from that 5 relevant document it will summarize your answer. So once you have retrieved your data, then the generator part comes. And generator is where you use your LLMs, and it could be any LLM. And in this tutorial, I will be using Llama 3, but you can use any other LLMs if you have access to it. So this is the RAG pipeline. You have to convert your text into chunks, then chunks into embeddings. Embeddings, you have to store it into vector store. Then you have to run your query. It will retrieve top 5 similar chunks, and the generator will finally give you the answer. Now, once you have created your RAG pipeline, you have also got the answer to the question that you have asked. It's time for the evaluation. You want to know whether the answer that has been given by this RAG is actually correct or not. So you will do the evaluation here. And the evaluation is different for different part. For retrieval, we have recall, precision, MMR. For generation, we have different evaluation metrics. We have faithfulness. Then we have some other metrics that we will see next. And then you can also evaluate the entire pipeline, the RAG pipeline itself. And there we can use latency, or even we can check output quality, the overall answer that the RAG is giving. Now let's talk about the retrieval metrics, so how we can evaluate it and what are the different metrics. The first one is recall, and it will measure the documents that have been retrieved by this RAG, how relevant they are or how important they are. So here I have taken an example. If you see here in a legal search tool, so if you are having a database of some legal, maybe some court cases or something. So in that case, you want to see whether the answer that has been given by or the RAG is actually correct or not, because then you cannot go and quote that this statement is correct unless and until you are sure that that is actually correct. So that is recall, where you have to check how relevant a document has been. Then the next one is precision. It will measure how many of the top K retrieved documents are actually relevant. So let's say if your retrieval has fetched 5 documents and 4 of them are relevant, so your precision will be around 0.8 or 80%. So your RAG has given you an answer which is 80% correct. Then we have MRR, mean reciprocal RAG, and this will try to assess the quality, and it will focus on the position of the first correct relevant result. So if you're saying that the top K is 5, that is, give me top 5 documents that are relevant to it, then it will check out of that top 5 how many, the first one, how correct is the first document. So if it find that the first document is not very correct, then it will go to the second one, and it say if it thinks that the second one is better than the first one, then it will find the probability given out of 5, what is the probability that the second one is good. So that is MMR. Excuse me. Now, if your recall is high, then it has found most of the documents to be correct. If your precision is high, then the answer that you have got is correct and it has less noise. Noise means the LLM has not put something on its own, but the answer is actually coming from the document that you have given to your RAG pipeline. And MMR is something it will rank the quality of